Go.
So we modeled all the fresh water in the whole world, and this is all the fresh water, but and water and salt water and everything. But this is all the salt water in the world, and this remaining percent is all the fresh water, not fresh water, but glaciers, frozen, and
it's
fresh water.
Inaccessible.
And then this. And then this percent is in glaciers and ice caps. And then this percent is all the fresh water, lakes, rivers, and everything. So, but then the total percentage of all the water that we can get to is, the accessible fresh water is this.
Actually, I thought it was that 1,000. This 10,000.
So I'm confused
It'd be 1,000. One of these would be 1,000.
because you guys are talking about in percents, right? And all of these guys out here know what percent means. Percent is each 100. They have way more than 100 out there, don't they? So
This is.
and we need some explanation, right?
Okay. So this is okay. So how we knew how to make all of these thousands is because it says 0.1. It has 0.1, and then how many of these goes into that? 10. How many of these go into that? 10. And then we thought this is 100, and then this goes into the 1,000, and then this is 4 zeros, which would be
3 zeros. It'd be 10,000 because the 4 zeros are backing it up because 3 zeros for the comma right here, and it'd be 10,000. And so we saw that. And,
So this isn't 1,000. This is 10,000. That's why we have so many of these.
So it takes 10,000 0.01 or 0.01%. This is the 0.01%.
But the real question
for
is
1,000.
So it takes 1,000 of these to make 100%. Which this is all the total accessible.
Actually, for all of this, it's a 10 because you have to.
But wouldn't it be, isn't that one?
Garrett was right because we modeled this as this.
So
And then this is 100. This is 10,000 times. This is 10,000 times as much as this. So that's. I know. I can understand how you're not confused there.
So this is all the fresh water that we can access and that we can use that's non-polluted. And this is, so this is the polluted and this is all the seawater. This is just this 2%, 2 whole percent is glaciers and ice caps. This is all the fresh water, but
and then there's polluted water,
Which
this takes away
and
most
then
of
there's
this.
polluted accessible water.
And then this is
I mean,
accessible. How much?
Accessible.
As it says, quote unquote, so total water on the earth that is actually accessible for humans to consume. So that's what this percentage is. Questions?
What about, but if it was actually 10,000, which it is up there, how come you don't have, the 10 would actually be it would be the 1%, because and then the 1 would be the only part of the 1,000, because the 1 would go to 1,000 times, but the 10 would actually,
It should be, the 1 should be a 10.
That's what I thought.
the 1 should be a 10 because it's a 10,000. It's not 1,000. Because,
Yeah, but
so you got to times it times 10 since it's not 1,000.
Yeah.
Actually, I kind of disagree with Sawyer because it was 0.01%, and that takes 10,000 of those to make 100%. So they have 10,000 up there. So that little tiny cube, 10,000 of those equals that. So they actually are right because.
Yeah, but actually 100 of those would have to equal that, wouldn't it? 100 there were 1,000 of those would actually equal that. So I don't get how it would be that way instead of a tiny little cube.
Okay.
A little cube would be 1,000.
Okay.
So do they have something to say about it? Is that what you guys want to talk about? Go ahead, Kelvin.
10 of 10,000 is 1%.
Exactly. No, not 1%. It's 0.01%.
It is. 10 out of 10,000 is 1%, and 1,000 out of 10,000 is 10%. So if you go one below 100, then you get 1%, and then if you go one below that, you'll get a 1 cube, which is 10 less than 1%.
So
It's mathematical. Okay. Thank you very much, Calvin.
So Stella. She has a question.
So when you're modeling the 10,000, why don't you show like the actual, so like what Sawyer said, when the 1 should be represented as the 10 for the 1,000. When you have all of your 10,000s together, how does that represent? You need to represent like with the 3 and the 2, and that's a scale model of the actual 10,000.
I thought it was going to be 10 because I thought that 1,000 would be 0.
But you want to see something really cool? But since it's times 10,
It'd be
if you put this is 100.
Yeah, so you put 100 of those 10 blocks, but I don't get how.
That's 100.
But
There's 1,000 of these.
yes, but that's only in that one instead of that 10,000. And so it'd have to
Yeah,
be
that's
10 for the 10,000
it'd have to
instead
be 10 for
of
the
1. So it'd actually be a 10
Argument.
instead of a 1.
This is not the 0.01%.
This would be 1%.
I don't get how that would be 0.
No,
Let's talk about it.
no, this is 0.10%. This is 0.01%. It takes 10 of these to make one of these, which is, and then it takes 10 of these. So one of these is 1%, and we have 1, and then this is 10,000, 0.01%, which equals 100%. I just thought of something. If it was 0.01 and you had to times that by 10, wouldn't it be 0.10 and to equal
It'd be 0.01. Or it'd be 0.01.
0.01, 0.
But actually the model,
That's what I'm
how we have the model is it's bigger number than it actually is. So, like, if you can put the 1 and it would equal that same number, it would have to be a 10 instead of a 1. Because it just wouldn't make sense.
Okay, I've already called him, so back.
So if you are trying to make the fractions bigger, because you can't model that unless you're cutting up the 1, which we're not allowed to do. So if you're making them bigger, then why would you use the 10 block? Because if you could use the 10 block by making it bigger, then if it was actually the 10 block, if you were modeling it with 100, wouldn't it be the 1? And then you wouldn't have to split it up.
Okay. Kaylee.
I think that I disagree with Sawyer because there isn't 10,000 tens in 10,000.
There's 1,000.
But there's 10,000 ones in 10,000.
See? So,
Because 0.01 times 10,000 equals 100%.
Yep.
And so there's 100% of water.
So we have gone about 3 minutes into recess, and we're going to pause this, okay?
I was so intelligent, my brain hurts.